Hello, guys. I'm very glad to stay here. I need to say thank you again, Fabio, for this opportunity. So let's start talking about this keynote. This will be very interesting. This project started as an experiment, as a laboratory for the company that I works needs, and later I will evolve and trying to add something features available for the most cloud provider available in the market. And here I will explain how we can create it, especially because the Docker Storm is not so new, but we have a lot of specific knowledge around the web explaining how to create it. So let's go. To start, I like to present some bands that I listen while I write my slides and code. Here we present Funkadelic with My Gut Brain. Funkadelic is a band from George Clinton. George Clinton is basically the father of psychedelic funk. Yes, 70s band. It's this album especially have a song called My Gut Brain. We have the opportunity to listen to one of the most underrated guitarists that we had in history. The name is called Ed Mazel. That's it. In the right side we have a band that I fall in love. It's completely different of old styles that I listen, because I like to listen jazz, classic music, and metal especially. Beyond Creation, the band from Canada. This guy that makes some noise in the technical death metal scenario because he uses a lot of unconventional techniques on guitar, especially with the heavy use of 8-string guitars. And listen, this is a very different approach to technical death music. Starting, I will present me. I'm Marcelo Pinheiro. I work on IT market since 2000, with the start of the e-commerce boom here in Brazil. I wrote in a lot of languages. I started with Active Server Page, PHP, later Java, C#, Visual Basic, BBNet, C#, C++, C, Python, Erlang, and others. And I have the opportunity to solve conflicts, being a tech lead, and trying to solve a lot of conflicts, especially. And today I work as a DevOps engineer on Work Company, a company based on New York. So let's start talking about infrastructure as a code. It's a not so new concept. It was created by the DevOps movement, and sometimes not all people understand how we can apply it on our daily work. So as I'm a developer, because I started to program before getting contact with the infrastructure things, and consequently changing my career to being a DevOps engineer, I will try to approach this way to qualify how we can use and how useful is infrastructure as a code. So one of the most traditional requirements that we have in projects is infrastructure. And unfortunately, this is a point that we have a lot of late projects because sometimes the clients have some kind of legacy data center, or they don't know how to create infrastructure because it is not the core business, of course. And sometimes we had only one or two or a team that have the knowledge to create this infrastructure. And consequently, creating servers in legacy data centers implies to write some bash scripts and code some knowledge that can be sparse in the data center and infrastructure. And this can be complicated when, for example, you have a server that is destroyed or accidentally deleted or turned off, for example. So infrastructure as a code was born in the DevOps movement, and how it can work. Basically, we try to write recipes that are human readable using source code. Today, we have a lot of command line interface that it can do a part of this, for sure. And with the popularity of the cloud providers like Amazon Web Services, Microsoft Azure, and Google Cloud, with the respective public APIs to provide not only servers but storage objects, storage disks, and all components related to create a virtual network. This do for this knowledge that are being shared with the public, especially with the use of the public APIs. Today, we have the opportunity to create and integrate these APIs using some techniques, and infrastructure as a code enables you to write in the higher level. So we can use, of course, a command line interface provided by AWS, Microsoft, and Google, but sometimes if you need to write a recipe that, for example, creates a server in the cloud, commonly we need to write some bash scripts. And depending if you need to use another providers like software as a service client or another technologies available, you still need to write some bash codes or try to plug it into your source code or whatever language you want to use. And sometimes it's not a very hard step to configure locally, but of course, you probably have some work to configure, because it not implies only to install clients. You need to set up configuration and so on. Okay, let's talk about Terraform. Terraform is basically a tool created by Hashcore. Hashcore is a very famous player in the market, especially when follows the DevOps movement. This guy is led by Michio Hashimoto, was created not only Terraform but Consul Nomad Vault and other nice tools that are being heavily adopted by the DevOps movement. So HashiCorp introduced it as an experiment. They had created the HashiCorp DSL, that is commonly called HCL. And this domain-specific language was evolved with the time, and it had been incorporated into Terraform. Is basically some kind of recipe that you define what provider you want to use and what resource you want to create. So this resource can be 7 instances, virtual networks, commonly called virtual private clouds, object storage like S3 and others, DNS zones and entries. You can manage a domain using RUB53, for example, or you can use DNS Simple as alternative too, and you can send emails using Mailgun and so on. We have a lot of research available and you can manage with Terraform. And for me, my personal opinion is the best solution to manage the research that not changes frequently. Here is a very important point, because if you have a very volatile environment that you need to destroy and create things all the time, Terraform maybe not fits very well your requirements. So the best way to use Terraform is define what requirements you want to solve, and later write all your recipes. If you have, for example, to need creating a Debras, Lambda functions or a set of functions, and you need to develop locally, I don't recommend to use Terraform for this way. So one of the best things about Terraform is the multi-cloud support. You can write recipes that interact with Amazon Web Services, Microsoft Azure, and Google Cloud. For this presentation, I will display some of my recipes that are written, especially to create at the first time a virtual private cloud into these 3 players. And with time, I evolved and changed my code to support a Docker storing cluster. So one tip, if you want to use it, you probably need to configure manually some steps into the Microsoft Azure portal, as the same with the Google Cloud. It's not so automatically mature as the DevOps, for example. So let's talk about code. I will show you some piece of code, of course, that I highlight, especially this model. Is called the Amazon Virtual Network. All of my research here available as some kind of postfix identifying it. So here in Terraform we have the concept of model. The model is basically a source folder where you can add the recipes. These recipes will be read by the Terraform binary. And one of the best things about it is you can reuse code here. So, for example, in this model, we call it Amazon Virtual Network here. We have the following directory where I have all my source code here. So in this piece of code now, I will define a virtual network. Is called a VPC on AWS. That's all stuff required. For a VPC, probably you need an internet gateway. Internet gateway is a component on AWS you can provide higher availability internet connection into your instance. But you need to, of course, make some configuration, additional configuration here. And, well, we have Elastic IP, a net gateway. A net gateway is basically a component that offers internet connection to outside from instance running in a private subnetworks. It's a very important point to highlight because you have public and private subnets into your VPC. So to offer internet connection to your private subnetworks, you need to use a net gateway. Otherwise, your service cannot reach any internet address. So we have a root table, subnets, and so on, a lot of resources. You can see all this code into my GitHub account that we will show you later. We have into this VPC a concept that I highly recommend to use, that is the SSA Bastion server. A Bastion server is basically a server that allows to connect into your private instance in your private subnet as a bastion. This is the best way to protect your servers against connections from outside world that are not allowed. So I highly recommend to use it. And in the end, we have a bastion server. Okay, let's try to making this working now. For sure, we have some emotion here because I need to rely on our connection. But this step will probably run into 4 or 5 minutes. We can take back to our code here. Okay. We have the same structure using the Microsoft Azure. And in Azure, we have on the first a high-level object called a resource group. Without the resource group, you can't create a virtual network into this cloud provider. So this is not so similar with AWS, but you can see some similarities. You need to create routes for your public and private networks, and have some kind of piece that is more complex than AWS, because AWS offers EBS volumes in a way that is more easy to improvise and compared with Microsoft Azure. So this is my tip. You need to read carefully this piece of code because it adds some components that are not usual because AWS abstracts it for you. So this is basically the same thing, but in Azure resource. We need to create a storage OS disk commonly in AWS you don't need to inform, or if you need to pass into your code, I want a storage disk, you don't need to refer where is the account that I want to use and so on. We have some more complicated steps to configure in this way. But it's not so hard to understand, and especially because I needed to compare AWS, Google, and Microsoft into common recipes. I take something near 3 weeks only reading the documents and get the same solution that is basically composed by a virtual network with a public subnet, private subnet, and associated master. Let's go walk into the Google Compute network code now. So here, this is the case that I need to highlight because the Google Compute documentation is not so good as you can find related posts and documentation outside Google. It's very hard to understand sometimes. There is a tip for Google, of course, to improve the document because it's not so understandable at first contact, and especially because the tags mechanism is sometimes can takes you for mistakes. For example, in my last week when I tried to provide on my cluster, especially because I have configured my server with the tag no IP, I don't have connection into my SSH instance, SSH server. So please take care of when you try to work with Google. Despite, okay, this is my experience. Of course, some of you can have a totally different experience working with it. But it's okay. The recipe is basically this. I don't have much things to highlight here. The recipe is especially curious because we have a few lines of code compared to Microsoft Azure that have a lot of source you need to write. So, okay. The cluster will be being created. I believe we can show to you here the servers are being displayed on my AWS panel and Microsoft panel too, and the same with the Google console panel. Okay, probably it will finish some research here. There is not a problem. Oh, that's finished. It's no bug in Terraform because I upgraded to the last week to the latest version, and this step is a post-provision step that I'm failing, and I already seen some issues related, especially with this case. There's not a problem. It's just to try to work again, to run the command again, and will generate the next step of this keynote that is related to Ansible. So I will create in my file. Okay, it's done. So this step is possible to generate Ansible. We call it Ansible inventory file that is available here. This is the managers and workers server IPs available. Okay. Trying back to our presentation, we will talk about Docker Swarm. So, Docker Swarm, in my opinion, is the most easy way to orchestrate containers available in the market for today. If you don't have knowledge about Docker Swarm works, it's basically an extension of Docker that you can run containers into a distributed cluster. And this cluster is composed by managers and work servers. The manager servers are responsible to manage all services running to the cluster. Commonly, the servers have less computational resources compared with the workers. Workers, of course, since these machines are responsible to run containers, basically all application containers, these servers especially we need to have more CPU and more RAM. And my experience working with Kubernetes and AWS ECS. This ECS is the EC2 container solution for AWS. ECS, you use a customized version of Docker that is managed by Amazon. And this service works very well, very well. It's very, very stable. But the concept of tasks and execution tasks and so on is not so simple to understand on the first contact. You have some time to understand how this mechanism works. Kubernetes have a lot of advanced features available, but you have a very high learning curve to understand it. So, in my opinion, Docker Swarm is the most simple solution to orchestrate, and I will explain why. We have basically two things, two concepts that we can use on a Docker Swarm. We have a service. A service is basically a container definition. If you use Docker and Compose, probably we will be get in contact with service, because when you write a Docker compose.yaml file, you commonly define the version and services that will run all things containerized into your application. So a service is basically a definition of a container that will run on the swarm. And since the version 1.13, yes, 13, before Docker changed the convention of releases, today a release is marked by the highest number of this release is related to the year, and the minor release is related to the month where the Docker Community Edition was launched. So in the version 1.13, we have the concepts of stacks. Stacks basically are a group of services where you can define to run into a Swarm cluster. For example, let's suppose you have a Node.js application that needs to connect into a RabbitMQ server. And so you define a RabbitMQ image as a container into your Docker Compose file, and you, of course, define your application to be containerized. You can build using Docker files and so on. In Docker Swarm, you created this service as a stack. In practice, is an extension of your Docker Compose file with some additional configurations related to deployment and restrictions that you want to apply into your containers. For example, I want to limit this container to 2 gigabytes of RAM, or it does not exceed some kind of cut of your CPU, and later. Okay, let's go back into your code. I will show you basically what is the structure of a Docker Compose stack file. That's here. You have a version. You need to define networks for your server. For example, here I will define my network driver for my app. And this driver will be an overlay driver. Here is an additional step that I will explain in my presentation later. That is traffic. And here I have 2 servers. One by one with this image that will use these networks. That will expose the port, ATT port, and I will want to deploy. This is a Docker stack definition. I want to deploy this container in the mode global. This implies in run one instance of my container in all worker servers. And here is my constraint, because I want to run this container only in nodes that runs as a worker node in Swarm. And additionally, I have some metadata to explain the Docker Swarm, and especially traffic, because highlighting traffic this is a load balancer specially developed for containers. I still use Nginx with dynamic configuration that implies to use console template to generate Nginx definition files to redirect requests to the containers. You can use traffic. The only requirement traffic needs is to run in manager mode into your Docker server. Basically, that's it. It's a very awesome project, and I highly recommend to use it. It's not so performatic like Nginx, but satisfies a lot if you have dynamic environments, and you need to handle a lot of QSOM URLs into your application. And in this compose file, I have two servers basically, one my one and one my two. You can see it's basically the same thing. This is just for purpose. You can, for example, define a RabbitMQ and your Node.js or another image that you want to use in your application. So, about Docker Swarm, it's basically this. Let's talk about Ansible. So, Ansible is, for me, one of the best available configuration management tools. And I need to, of course, to highlight CF Engine. CF Engine was a project created in '93, yes, 24 years ago. And this is the first approach to configure servers based on recipes. And as the same with the Chef, Puppet, and SaltStack, CF Engine uses a master agent architecture. You have a master server running into a remote machine. This server handles all database responsible to configure nodes, and you need to install a client into your node server to be configured by the master. And Ansible works in a totally different way. Ansible is a masterless architecture. You simply need to have your SSH keys into your server. It can be a local machine or a remote server with Ansible installed. And you simply run a command and Ansible works. That is it. It's very, very simple. And for today, I will use Ansible to create and configure my Docker Swarm cluster. And one of the best things I like to talk about Ansible is the idempotent support. When you need to use some command line tools, for example, AWS, you need to provide idempotency into your code. Ansible is smart enough to detect when you need to apply to change some things into your server, for example. And in this case, on this keynote, I will present how to deploy application that I showed before. For now. Okay. So this step probably will take some time. Ansible will connect into our servers. This architecture, I forgot to say, we have in the total as 18 servers. 6 servers on AWS, 6 on Microsoft Azure, and 6 on Google Cloud. So we have 3 managers and 3 workers for each cloud provider. And let's go deep into our code. So let's start about, give me a minute to search here. Okay, that's it. We have here the domain file of my Ansible recipe. We set up a Docker. Basically, it is responsible to install Docker into these servers. We have later a step that will set up the Swarm cluster, and finally set up traffic into our cluster to act as a load balancer to our container that will run into this cluster. And finally, we will deploy the stack. So here is basically the Mary side recipe for the Docker installation. My suggestion is always, when possible, use the documentation to proceed with the install. For now, Docker have the apt key. I'm using an Ubuntu server, the latest version that is 1604 LTS. Yes, that's it. And I will import the apt key, and I will set up additional apt search list called docker.list into this path, referring the Ubuntu package repository. And later, we'll simply install, as you can see here, Docker CA is the Docker Community Edition, because since the launch of Moby, Docker changed a lot of things, and the Docker distribution of Docker will call it Docker CA. And for Docker Enterprise Edition, Docker have Docker EA, for example. So, okay, some additional configuration here. This is not mandatory, but I recommend to define the experimental as true into this path to enable some experimental features if you want to test Docker some features that are not being launched yet. I need to explain in my case why I do use it. I started to use Docker Swarm into version 1.12, yes. And the concept of stacks are not been deployed as a release feature, a stable release feature in the release. So I need to enable the stack support informing the experimental true. So in the end, I will ensure Docker install it, and that's it. As you can see, I will still installing Docker into our cluster here. So give me a minute, please. Don't need to check whether it's, especially with step it's running now. Okay, install Docker. Just to install it. Okay. Let's go explaining the most funny part of this presentation, as my opinion. After a lot of search, I found a guy that wrote a idempotent recipe to create a cluster from scratch. This recipe basically starts identifying what servers are running with the Docker Swarm support. And for all servers based on this task, we have some bash script here to detect if it is running on Swarm feature. You create a pool of operational Swarm managers and another pool of managers that not runs in Swarm mode. And it does the same with the Swarm workers. And why you need to split these steps? Because in Swarm cluster you need to bootstrap only one server, and this server will generate a token. Two tokens in really, a master token and a worker token. And since for each it's totally different, each from another, you need to split these steps into two. So let's go here. Okay, this is the step where you start the Swarm cluster. The units. You get the first one of one manager of this list. This instruction add host will create a host variable into your Ansible inventory, and you get all IPs of the Swarm managers and Swarm workers here. So let's look into, okay, give him a minute, please. Yes, you create this, you initialize your Swarm cluster, and you add this cluster into an operational Swarm manager group. And after creating the Swarm cluster in one server, you need to get the Docker Swarm join token. The join token is the key responsible to authenticate your Swarm server into the cluster. And okay, populate list of manager IPs. Oh yes, you retrieve the token, and later you add all server IPs that are not operational yet. So based on the token that you retrieved from the first server, you inform it here, and this is a very important step to explain. When you try to join a Swarm cluster, you need to refer into a multi-cloud configuration the public IP address. Otherwise, it not works because the common documentation will explain to you to use the private IP. Into a multi-cloud Swarm cluster, you need to pass the public IP. And this is the same with your Swarm worker nodes. Okay, that's it. Here we have our 18 servers running now with our application previously talked that we will show to you. Okay, let's go here. As an example, I will try to make some requests here. I will get one of our main clusters here from AWS. Ta-da, we have a running container into this cluster. As you can see, please take care of the special attention to the host name. The host name is basically the name of the container running the cluster. Let's try to use an IP from a Microsoft Azure cluster, and I will request the woman I2. Okay, it's working. As you can see, the host name will change during this step. And later, to finish, I will request a cluster into our Google Cloud server. And as you can see again, the host name differs between our requests. That's it. A very important point to explain here. When you install traffic into your cluster, you need to specify traffic to run only in Swarm Manager nodes. And you don't need to configure traffic to run in worker nodes because it listens to the Docker Swarm API. So you don't need to run traffic on it. You need to only expose traffic into your Swarm Manager nodes to work. And finishing, forgot to open here my traffic recipe. Okay, that's it. And to finishing this presentation, basically, I will check its traffic access as a service on Swarm. I made some steps here because the Docker module for Ansible is not very stable sometimes. So sometimes it's better to create your dependency using a custom script to handle it. And finally, as I explained before, you create traffic to run in mode global only on manager nodes. And you publish the HTTP port and the client port. No, it's not the client port, sorry. It's the console panel for traffic that runs on 1880 and the DPS port. And since the traffic needs to run as in the privileged mode, you can expose the socket for Docker socket to traffic, listen, edit, and then some additional configuration here, and that's it. So, as I explained before, if you want to change here, we have or stack running into these 18 servers available. Okay, guys, that's it. If you have some questions, feel free. And okay, it can be a very dense content to display here, but I know. And my experience is to using Docker Sound Cluster. It's a very, very stable tool. And try to adopt it. I think this solves a lot of solutions, a lot of problems you can have about infrastructure related, especially when you have some application that needs to handle a lot of domains and so on. In this case, you can use traffic as a load balancer solution too. And again, traffic is not so performatic compared with Nginx, but it solves a very dramatic configuration problem that is, I can dispatch my request for what container I have running on my cloud Docker cluster. The most traditional solution is to use Nginx combined with console. It works, of course, but you need to take care of a console cluster to make it working as you want. No questions here? Okay, guys. Thank you.